a massive warm welcome to everybody joining us on our Ekahau webinar series, where today we are cutting the cord and taking you through everything you need to know and consider to creating a wireless only or a wireless first environment. I wonder if there's going to be anything that requires some cables still. I guess we're going to have to find out during the show. But before we kick off, Mac, why don't you do a quick round of introductions for everybody?
Totally. So for all of you that haven't heard about us, it's Matt and Mark. We are directors of ECSC University and product marketing, joined by Stu, our amazing sales engineer from To Awesome Canada. Thank you very much for joining. And today, guys, we are going to discuss wireless first. So everything that comes in, almost everything, without the cable. And we'll be discussing pros, cons, why you would like to consider going wireless first. What are the challenges and thoughts that you might have before you decide to do that? So let's crack on.
Yeah, of course we can. And well, one of the first things you're probably thinking as you join this webinar today is going for a wireless first deployment worth it? Well, we thought we would put together a quick list of some pros and some cons. So first of all, starting off with the pros side, where if you have an environment where it is predominantly wireless first, where you're providing the majority of the connectivity to your client devices via the wireless, this means that you're going to be able to save on not running so many cables. Perhaps you don't need to run a cable for every single user to every single desk in your office or your manufacturing plant or wherever your location is. That's going to save a lot of cable runs. And I actually have a question I wanted to ask you in the audience is, from your experience, when you have been quoted by the installation team or the cable team, in a dollar amount, like how much on average or roughly would you say you're typically quoted for a cable run to a deployment for the desks and to different devices throughout the environment? Is it $100 or $1,000, $5,000, $200? Let me know roughly in the comments how much you're being quoted or how much you pay for cable runs per cable run, please, because we'll come back to that a little bit later on. Good answer of it depends, but we just want to get some rough numbers for now, and we're going to actually come back to that in a little bit of time later on. So of course, if you're running less cables, that's also going to mean that you're going to be requiring less switch ports. And if you have less switch port requirements, this is also going to mean that you're going to require less switches, and less switches means less costs. And again, another question for the audience, what would you say an average price is for a 24-port PoE switch that you would buy from a typical vendor? Again, just a rough cost for your switches, and yeah, we'll come back to that a little bit later on in the show. So less cables to run, less switch ports required, less switches required. That also then means that you're going to be using less energy because you have less switches that you need to power and provide the energy to. So that's going to save some costs on the power, but also, better for the environment as well. Less clutter. One of the things we've noticed a big change and shift from in the last couple of years is no longer the requirement to have physical desk phones sat on the desk, because all of these types of devices have now moved into being soft devices capable by running either on your phone as an application or on your laptop. So that means that our users are much more mobile. They are moving around the office, and they're not going to be tied to just that one location. So it means the users can be sat at their desk and they can take a call, or they can move to a meeting room, they can take a call. As they're just traversing through the office, it just makes it easier that they can be taking and making these phone calls. So of course that makes, for me as a user, I'm much happier not being tied to the one location and having to be at my desk to answer the phone, or I can actually take it from my laptop anywhere. I'm sure a lot of you here as well are probably feeling the same. So yeah, that makes us a little bit happier, and it's just a lot easier to manage, easier to upgrade if there's less devices that we need to cross our fingers and pray to the networking gods when you roll out that new firmware upgrade, that the device, it takes the image, it reloads, and it comes back online. Less of that to worry about. And then we've got a point there about it being less expensive. And I'll come back to that in a few moments' time when Mac has gone through a couple of the cons, and we'll take a look at a couple of the other slides. And then the information that you've sent over in the chat, thank you so much, everyone. I saw all of it coming through. I'll take a look at that because I've put together a quick, I refer to it as a quick and dirty cost calculator for the benefits of potentially going to a wireless first environment. And I'm going to use some of those numbers that you have just thrown over there. So Mac, that was a few of the pros. How about some of the cons?
Okay, so for me personally, close to none. Okay, so I wouldn't say we have too many cons with going wireless first, but if I had to choose some, I would say that sometimes with wireless first, even if you scope it correctly, you're scoping it for most of the time. Sometimes you might struggle with capacity. You have no cables to fall over to. If you have way more clients doing way more things than you scoped for, you might struggle a little bit with some increased airtime utilization that will translate to slower Wi-Fi and lower or higher latency. So be careful there. On the other hand, you don't want to overscope your wireless first network because it can bring costs up by quite a lot of money just to cater for just one event a year. So scope your capacity requirements correctly and you should be fine. But it can be a con, right? Without any cables at your desk. Ideally, it requires 6 gigahertz enabled devices. We've decided to put it as a con because 6 gigs devices, they are still quite sparse. Yes, you have new MacBooks, new tablets from Apple, and you have new Android phones. Most of them supporting 6 gigahertz right now, but still iPhones, they don't support 6 gigahertz. Some 6 gigs enabled clients, they can be a little bit on the expensive side. Not all the corporate environments, they can afford going for 6 gigahertz devices. So even if you have super solid wireless first environment from the infrastructure perspective, you might have clients that don't support it. So you won't benefit from the extra capacity added by the tertiary 6 gigahertz radio in every single access point. And then it might require more access points, ideally tri-band. Yeah, so you need to have that 6 gigahertz ideally. We will have a proper demo later showing you the difference between dual band APs versus tri-band APs. How do you optimize these networks? How do you design for these networks? What are the challenges with both dual band and tri-band? Because you design for them differently, okay? You treat them differently. And you might need to have a little bit more access points if you have all the devices on your wireless network, right? And you might require more PoE, so more expensive switches. Of course, you will have way less switches to consider if you're not cabling up your desks. Matt will show you in a calculator in a second, but your switches might be a little bit more expensive. Since we are here talking about PoE, be mindful when you're going for bigger, newer access points, you will have 2.4, 5, and 6 gigahertz radios, most likely client serving, additional monitoring radios, switching between channels to look for security threats without losing, airtime, without going off channel to scan against vulnerabilities and affecting clients it serves. So you'll have 4 radios, at least from the Wi-Fi perspective, in mid and top range access points. You will probably also have some IoT, right, radios like Thread or BLE. We'll talk about BLE a little bit later. You might have some USB ports for extra modules. You might have multiple RJ45 connectors in the access point. All of these parts, all of these things that can require more PoE power. So what happens when you have, let's say, 30 watts on a PoE and your access point draws up to, I don't know, 45? Thankfully, most vendors, first thing they do, they take it off the MIMO operation from 2.4 gigahertz radios. So if you have 2.4 and 5 and 6, 4x4 across all frequencies, first 2.4 will become 2x2, for example, okay? Then the next thing on the chopping list will be the USB port, perhaps, then probably 5 gigs, and then probably 6 gigs. So hopefully you won't see any deterioration of capacity, of capabilities of the AP on a 30 watts port, tri-band radio on 5 and 6 gigahertz bands, hopefully. And that's probably it when it comes to cons. I would also add one more pro. If you have more access points and they are new, latest and greatest sexy APs, they look great on the ceiling, right? So yeah, I like looking at it. That's it.
All right. Well, before I take you to the calculator, let's just cover the ideal scenario potentially for cabling your device, cabling your access points. So in this scenario, where you have gone to a wireless first deployment, now your access points become a lot more depended on, and you may need to have a little bit more of confidence in the redundancy of the access point. So in this scenario, you may potentially want to actually run 2 cables to per AP. And for 2 reasons you may want to do this is, first of all, is that if you have a cable fault go to one of the access points, there's another backup cable run that it can, power and provide that wireless connectivity to your access point. So if you are going to go down the model of running 2 cables per AP, when it comes to your switches and how you would run the cable from the switches to your access points, let's say we've got access point 1 here, you would have, let's say, switch 1 and then switch 2. You would run 1 cable from switch 1 to AP1, and you run 1 cable from switch 2 to AP1 as well. So you get that redundancy on the switch side and on the cabling side as well. So if you was to for some reason the cleaner comes in, as they're cleaning, they turn off the power supply to one of the comms rooms or something that's powering the switch. When one switch goes down, it doesn't take down all of your access points. You've got some backup and redundancy there. Obviously, there's some costs associated to that. So if you were to go on the other option here of the good option of 1 cable per access point, what you'd want to do in your environment is kind of, you call it salt and pepper still, and spread it out between the switches so that if you are to lose a switch, you don't completely lose all of the access points in one location. So in those 4 access points, example there, 2 go to one switch and then 2 go to another switch, just to create a little bit of physical redundancy. Because even though we're talking about a wireless first and wireless only deployment, I saw a few of you in the chat say, well, we need to run cables to our access points. And yes, of course, we do need some cables sometimes. So it's good to discuss some cabling here as well. Okay, Mac, this one, and then we will take a look at the calculator.
Sure, we need to have some cables sometimes. Yeah, sometimes. I would say like for every access point, right? At least one. And by the way, guys, if I'm disappearing from the Zoom meeting, it means I'm losing my teleprompter. So I'm just like quickly restarting the docking station. Something happened today. So yeah, worry not. I will be back in 5 seconds. So guys, what happens when you have these 2 scenarios, perfect and good, and when you lose one of the redundancy switches? In the perfect condition, when you had 2 cables per access point, nothing dodgy happens, really. Just lose the redundancy. All the access points that remain online, and your capacity or coverage doesn't change. When you move to the good side with just 1 cable and salt and peppered between different physical switches, then you lose potentially at least half of the access points, and that translates to less coverage, to lower MCS rates, lower data rates, and lower capacity. And when that happens, wireless first environments can struggle. Okay, so be careful with that. If you can afford the perfect scenario, great, by all means.
Okay, great. So let me show you this quick calculator that I made earlier on today. Now, first of all, caveats, this was, like I said, a quick and dirty calculator that I put together earlier on today, because when we had in the slide to say that it is less expensive to go towards a wireless first only deployment, I actually wanted to back it up with at least some math and some numbers. And I'm actually going to use the numbers that you have provided in the chat earlier. And crazily is that we have a member of the team, Jacob, who went through all of the chat, all your messages, and for the cable runs, the average amount that you said for per cable run was just a little bit over $500, so $500 and nearly $10, which is pretty much what I've got up here for an estimated cable cost run. And then for the switches as well, it came in at average just under 5,000, so 4,800. So I'm going to leave those numbers alone for now. Now let's take a look at, let's say that you have got 200 employees that you want to provide this wireless first deployment for. If you've got 200 employees, what I've done here is just some simple math for some quick capacity calculations on roughly the amount of access points we're going to need. Yes, there's some caveats around applications, devices, etc., etc. But rule of thumb, what I've done here is effectively for 200 employees, I've divided that by 20 employees per AP, which has given us 10 access points that we've come out at. Okay. So the next thing I'm looking at is if we go down that perfect scenario of running 2 access points to each switch, how many 24 port switches are we going to need to power all of these access points in this wireless only deployment? I've gone with 2 to provide that redundancy, plus also if we need to cable up some other devices as well. Now, if we was not going for a wireless first deployment, and we were actually going to be running cables to every single desk, then that would have been 200 cable runs. But because we're not, we're going to be doing a wireless only deployment. That means that we're saving roughly around 180 cable runs. The other thing that we was taken into consideration is how many switches have we saved by going for a wireless only deployment? Well, if you needed to run 200 cables to 200 desks and connect them back to switches, then on average, you probably would have needed around somewhere between 8, 9, or 10 switches. So I thought I'd be a little bit conservative here and go with 6 switches. So just on some rough numbers based on what you have told us in the chat, the cable runs coming in at around $500 per cable run sometimes, and a 24 port switch on average costing $5,000. To go for a wireless first or a wireless only deployment, you could have a potential savings of around $120,000. And yes, of course, there are some caveats. You might spend a bit more on some access points, and we haven't calculated the cost of how much energy you would have saved by having 2 switches instead of 8 or 9 or 10 switches. I just thought, on average, roughly, how much you could potentially save. But if I was to change this number now from 200 employees to, I don't know, maybe you've got a large office deployment where you've got 1,000 employees, and then just keeping those same numbers, you could have a potential saving here of, just around $600,000 potentially. So yes, I know this isn't perfect, and we've come to some numbers together between us. It seems like we're all on the same page here somehow, magically. I don't know how that happened, but the webinar gods were on our side today. Thank you very much. But yeah, I thought that was quite interesting, so I would share that with you all today. So we can now carry on back with the slides. Yeah, I agree, dark mode. But is there even such a thing as dark mode for Google Sheets and Google stuff like that? Because I wish there was. I'm a big fan of dark mode, like our products. And something else for us to take into consideration is if you're going for a wireless first or a wireless only deployment, does it have to only be Wi-Fi? Well, most access points now that you get from your vendors, they will typically come with a BLE radio inside of them. And when you're providing the coverage for your access points in your environment from Wi-Fi, there's a pretty good chance that you're also probably providing Bluetooth or BLE coverage as well. And that means that you can leverage the BLE for a whole magnitude of things as well that people may or may not want to use for a wireless only deployment, not just leveraging the power of Wi-Fi here. But what we thought was quite interesting is that you can actually see in Ekahau, when you're creating your predictive models, what that potential BLE coverage will look like. So that's it on the screen for now. Mac will talk you through some of the benefits of also having Wi-Fi and BLE in the same environment, but we'll give you a demo later on how you can actually plan and design your Bluetooth coverage later on in Ekahau AI Pro.
Yeah, so guys, the sad reality is that most of us, we have access to BLE radios inside enterprise-grade access points. Most of these APs have programmable radios these days that you can use for multiple different purposes. And almost none of us uses this BLE radios built into the APs. Okay, that's the reality. So let me tell you why you would like to consider using BLE built into your APs. So first thing is to transmit beacons. So try to imagine your APs, multiple of these access points, they transmit beacons like very frequently. And then you're walking around with your mobile phone, okay? And then your mobile phone listens to these beacons, and based on the knowledge of the location of the APs and the time, the RSSI of the beacons it heard, it can trilaterate its location, and then you have like blue dot on the map. It's like a turn-by-turn navigation. That's one use case, very strong one. Some vendors even have like Mist, they have like the arrays of directional BLE radios where it's even more accurate to have the blue dot on the map. by default, okay? And it's easy peasy, it's really easy to deploy. Then the second thing that you might benefit from BLE radios is to receive beacons. So your radios in the access points, they listen to beacons from BLE tags. So think of it as an assets tracking. You attach a small BLE tag to your, I don't know, your cart, your laptop, your power tool in a warehouse, whatever. And if the accuracy of tracking your BLE tags based on trilateration from the AP's perspective now is good enough for you, then you can have like 3 to 5 meters assets tracking accuracy without investing in an extra infrastructure. So that's quite strong, okay? And you can even buy BLE tags that don't require battery these days. They are powered by movement, which is crazy. It's crazy, and it works. We've tested it properly with Matt. And you can also use programmable BLE radios as the IoT gateways. So that's a strong use case. You can have occupancy sensors. You can have smart lights, environmental sensors for temperature, for humidity, for all this stuff like doors open, close. And you don't need to really buy third-party gateways. You can use what you have installed in your enterprise access points to be your IoT gateway for BLE. And also some vendors like Meraki, for example, they use BLE as a backup mechanism. So when one of the access points loses access to the network, they will inform the neighbor access points about the lost connection, okay? If you have, for example, mesh disabled. So BLE can be a powerful ally in your toolbox when you start using it. So at least consider it because you already have it, most likely.
Yep, and we had a question come in on the Q&A from Gianfranco just asking what is BLE, and BLE stands for Bluetooth Low Energy. And what Mac was saying is that typically most of your enterprise grade access points will have a BLE or Bluetooth radio inside of them. And of course, all of our personal devices, they have these BLE radios inside of them as well for connecting to your headphones, your mouse, trackpad, keyboard, you name it. It's all using BLE. So there's a lot of use cases for more and more of these devices for tracking how many people in rooms, if a meeting is occupied, health and safety reasons. So yeah, when you come to design your wireless networks with Ekahau, you can also not just design for Wi-Fi, but also take into consideration Bluetooth Low Energy. So one of the questions we knew we was going to get on the webinar today was like, well, if we are going into a wireless first or wireless only deployment, are there any devices that we still need to cable? And well, of course, our access points, we need to run cables to them currently still. And then our kind of recommendation is that if you have a device that doesn't physically move, that you've got a TV that's statically on a wall and it never moves, then cable it, run a cable to it. It doesn't need to be wireless. If you have vending machines or other types of IoT devices around your environment that need to connect to the network, don't use those for wireless. Get them on the local network and get them cabled up. And printers is one of the ones that we definitely recommend that you get cabled to your local area network. And then also take into consideration is disabling the wireless on the printers. We see it a lot that these printers will have by default the wireless enabled, and then they kind of act as some form of wireless access point or device that's in your environment causing contention, but also sometimes a weak method of access to your corporate local network. So these devices, if you have them in your environment, you can run cables to these, no problem at all, and we won't be offended. And Mac, I know you put this slide together, but we were talking with the team, we thought you missed a bit of a trick here, because since you used a bird, you could have used a starling, and then it would have been a bit of a pun going on there, but never mind, maybe next time.
Or instead of a bird, I could have put like an X, right?
Yeah, true. Well, maybe we should have an X that goes across it now.
Okay, so now, guys, I've mentioned at the beginning that there is a difference in approach when it comes to designing, optimizing, validating your dual band and tri-band wireless first networks. Okay, so I will start with the dual band and introduce it here. Then Matthew will talk you through the tri-band, and then we will go through a very nice demo of dual band versus tri-band and what to think about how to design for it and this kind of juicy stuff. So first of all, dual band, what we mean by this is just 2.4 and 5 gigahertz radios inside an access point. If you have the same number of dual band and tri-band, and dual band, of course, gives you less capacity. If you want to have more capacity with dual band to match the tri-band design, then you need to simply have more radios. You need to have more access points. And in the design here, like, in the bottom, you can see that there is a massive difference in the number of the APs. So for this particular design that we will be demoing in like 2 minutes, I needed to use 28 dual band APs to have pretty much the same capacity as 17 tri-band APs. So going for a little bit more expensive, maybe APs like tri-band 6 gigs enabled APs will probably be still cheaper, like massively cheaper than dual band APs. And that's because not only because of the fact that you need to have more radios if you're using dual bands and require high capacity, but if you want to reduce your CCI, which stands for cross-channel interference, which is the same name for same channel overlapping or same channel contention, then you need to start being creative with dual band APs because we have a limited number of channels. Okay, we can't be using more APs than like every, I don't know, like 12 meters or 15-ish meters. It's like just a ballpark figure in the open space. Sometimes it's fine to have them like every 10 meters if your environment allows it. But let's say that 12 meters, everything closer than 12 meters in dual band world, in the omnidirectional internal world, I would feel a little bit uncomfortable, okay, if you don't have anything that blocks the signal between these APs. And if you need to cram more radios and start having APs, let's say like every 8 meters now to satisfy the capacity in dual band, now you start to have way too many access points, covering way too much, contributing to CCI, especially across the floors with your neighbors, with multi-tenancy buildings, in city centers. So you have to be super careful with that. Adding more radios when you can't contain CCI will be very lethal to the performance of your Wi-Fi network. So you can't just do that. You have to be a little bit more creative. So now you have to be designing your Wi-Fi network with patch antennas pointing down from the ceiling, about the same height as the omnidirectionals, but now they will be covering less. You will be reusing frequency better, but then you have to consider the cost of the antenna, the cost of the access point, the cable between the AP and antenna, mounting of the antenna, and more APs and antennas. And that becomes a little bit on the expensive side. So now, Matt, talk us through the tri-band challenges and thoughts, and I will prepare the lab to show in a second.
Yeah, so, with going down the path of having a tri-band capable access point, and what we mean by that is an access point that supports 2.4, 5, and 6 gigahertz, what that means is that the more client devices that come into your environment that actually support the 6 gigahertz frequency, there are multiple devices that are out there now, the more of the 6 gigahertz capable devices that come into your environment and they start to use the 6 gigahertz frequency band, if we just take it back a second and try and put it in as much as of a simple context as possible. If you imagine that we have 2 lanes at the moment, had 2 lanes for our Wi-Fi traffic beforehand, one for 2.4 gigahertz and the other one for 5 gigahertz. That meant all of our client devices, they had to either be using the 2.4 or the 5 gigahertz lane to send their data and connect to the wireless network. Well, with 6 gigahertz, that has effectively given us an additional lane. So we've got 3 lanes now that our newer client devices and access points can use. So the more client devices that come into our environment that connect to our 6 gigahertz access points that are 6 gigahertz capable can use that 3rd lane now. And the more devices that end up going to that 3rd lane, that means lanes 1 and 2 become less congested. So actually, the more 6 gigahertz clients that you can get into your environment, it's actually going to benefit your older devices as well, therefore making overall improvements for the network and helping you out of those capacity issues that you may be running into in your environment. And we'll give you some demonstrations of that right now. So shall I stop sharing so you can take over, sir?
Sure. Okay, let's do that. Share screen 1. Sure, there you go. You should see my screen now. Let me move that higher up. So, guys, this is Ekahau AI Pro. And what I have on the screen now is a fairly big office, single floor. And now I'm using tri-band AP. So when I zoom into like any access point, let's say like this one here, you can see that it's on the channel 1, 100, and 117. So 2.45 gigahertz and 6 gigahertz. So what I wanted to highlight here is the success criteria. So I highlight my inclusion area around the office, and let's see what's inside. Since it's a massive office, we will have quite a lot of devices. What I assumed here we'll have an equal spread of 5 and 6 gigahertz capable devices. Okay, so I appreciate not all of them will be 6 gigahertz enabled on day one, but most of them, the new ones especially, will be 6 gigs capable. So what we have here is 175 Wi-Fi 5 laptops and Wi-Fi 5 smartphones, and then 175 Wi-Fi 6E laptops and Wi-Fi 6E smartphones. What we've also assumed is that when you are using a laptop quite heavily, like on a Zoom call, for example, that's what you use, like between 2 to 4 megs per second. When you are sitting on a Zoom call, you won't be using your smartphone, okay, too much. It might be like on a background sync, you might be checking your email, whatever, but you won't be streaming your Netflix or YouTube or anything else. So one device will have quite high-ish SLA, so 4 megs, and another device, the secondary device, will have quite low SLA, like 1 meg or even lower than that. So we don't want to overkill it here with scoping the capacity. And now when you ask Ekahau if your design will cater for this capacity, the capacity must be quite practical. Okay, so don't overdo it. If you are designing for 500 users, you probably don't need to assume that you will have 500 users in the office all of the time, because some of the users will be on holidays, in the toilet, grabbing coffee, whatever. And when you have like 350 users at peaks in the office, not all of them will have 4 devices. Some of them will have 2 devices. Some of them will have 3. Out of these devices that they carry with them, not all of them will be even connected to Wi-Fi. If they are, one device will be used at a time, and then another device or 2 devices or 3 devices will be sitting on the background sync. And when you scope the applications being used by these devices, then not all the devices will be using all the applications at the same time, right? So you can't add browsing plus video conferencing plus audio streaming plus video streaming. No, you'll be doing like 1, maximum 2 applications like that at any given time. So I think this is quite practical for the size of this office. I counted the seats there, so it's quite practical there. And we are designing against Ekahau best practices, so that's the Ekahau best practices is a coverage requirements. So I will show you instead of just talking about it. It's like next 67 signal strength on 5 and 6 gigahertz primary and secondary. Secondary is required for roaming, for redundancy, for higher capacity. It's great to have that stuff. And then typical things. So we don't want to have lower SNR than 25 dBs, which translates to QAM64 modulation. So high data rates, data rate minimum 24 megs per second. And we don't want to have any channel interference, any CCI, same channel overlapping, 1 at any given channel. Everything more than that, we consider a problem in a design. Simple. 2.4, no requirements there. A best effort band. Okay, so let me close that. So now, guys, what do you feel? What do you think? Let me know in the chat. What do you think about the design for this particular network? Let me show you some distances between the APs. So this is like 12 meters. These guys are like 11 and a half, maybe 12, 13 meters there, and then 12 meters again, stuff like that. So we have like 17 tri-band APs to cover the office that is 70 meters wide. Is that enough? Is it not enough? Do you feel it's a good design, bad design? Would you have done anything differently? Design looks good to me. Surely, yeah, Mac didn't do this. Oh, that's Matthew's. Okay, almost as good as I could do. Cool, guys. So I think that this design for omnidirectional APs is as good as it can get, pretty much. Like, I know that you can do it in multiple ways. There is no like one size fits all. Maybe you can't mount APs everywhere where I planned them to be mounted. Maybe you have some featured walls, featured ceilings, you can't touch them, you can't run a cable, whatever. But it seems like a good density of the APs. Signal strength is fine. Then secondary signal strength most likely is fine as well. So sometimes like in the kitchen or in the corner here and there, you don't have a secondary signal strength. And that's not a problem. That's perfectly fine if you don't have it in the area where you don't have to roam. So I feel it's great. But now when I ask Ekahau, okay, against the requirements specified for the capacity, this 175 devices of each type, 4 types of devices, am I passing capacity health requirements? So let me check that. I'm going to capacity health. And now this is a tri-band network. Ekahau feels that 17 APs, 6 gigs enabled, can easily cater for my requirements. So life is good, okay? I can have wireless first office with 17 freaking access points. So probably 1 switch, maybe 2 because of cable length. Easy peasy, lemon squeezy. Cheap, cheerful, and powerful, beautiful, okay, and easy. Everyone can do the design like this. Internal, directional, cheap APs, typical environment, typical enterprise grade access points. Now, let me change all these access points to a little bit older ones. So currently we are using here, for this example, Cisco 9166, which is a flagship AP from Cisco. I could have used Aruba or Mist or whatever. All the flagship APs, they will be similar. Okay, they're all amazing. And for the sake of this example, I will be downgrading these access points to whatever most of us have these days, like 9120s or 9130s from Cisco.
Now,
yes.
Before you do that, you've had a request if you could show your network health visualization.
Network health visualization. This is my network health visualization, and that's a pass or fail. When it's red, it fails. But when I switch to network issues, it will color grade my problem, which is yellow. It means secondary signal strength in the highlighted areas. I don't have any other issues. I don't have CCI. So when I go to channel interference, there is no CCI at all. The network really looks healthy from a design perspective. Okay, I hope that this answers this question. So now let me disable the visualization. I will select all access points. I will edit multiple selected APs, and then I will change the model of the access point from 9966 to 9130, which is the flagship access point from 2 years ago. Okay, it's like dual band without 6 gigahertz radio. And all the attributes, they stay the same. I haven't changed anything when it comes to power. It's all default, ceiling mounted, 2.4 meters above the ground, easy peasy lemon squeezy. I will quickly recalculate the channels because now they all sit on channel 1 and 36. So let me do a quick channel recalculation. Let's not disable 2.4 gigahertz radios in this example. 1, 6, and 11, always, guys, 1, 6, and 11, never use different channels. 20 megahertz on 5 gigs. Cool. I hit create, so Ekahau will quickly calculate the channels for me across both bands. I have 100% pass. So now when I go to, let's say, network issues again, this shows me network issues, network health from the coverage perspective, and coverage will be very similar, right, between 9130 and 9166. But I haven't changed my capacity requirements. I still have this 600 or 700, whatever devices. When I go to capacity health with dual band APs now, most of it fails, okay? Most of it fails, and it's really, really bad. It fails pretty much everywhere. So when I switch from tri-band to dual band, I lose capacity. Tons of capacity is lost, and the cost of the network, of maintaining the network, is pretty much the same, okay? So be mindful of that. Now, let's discuss quickly, how would you have to redesign this network with dual band APs if you wanted to have the same capacity as you had with tri-band APs? So tri-band APs, it was enough for me to have 17 of them, okay? Thomas says increase channel width. But if I increase channel width, then what's going to happen in the multi-tenancy building? I will increase CCI and I will hurt my network even more. So if I increase the CCI, then the airtime utilization, the contention will go up, and up, the higher the CCI gets, and it will be slower. I won't be having any benefits from wider channels there, okay? So it might work if you have no neighbors, but here it probably won't. More APs and lower power. I kind of agree and disagree at the same time. If I add more APs and lower power, what I'm hurting mostly is the clients close to the access point, close to me, because their MCS rates, their data rates will drop significantly because over the first several meters away from the AP, the RSSI loss is very steep. Then you move further away from the AP, where the APs contribute to CCI, and reducing transmitting power level doesn't really change the CCI, okay? Very, very, very minimal effect, positive effect on lowering CCI. So what I would do, I will open up a different project. So remember the position of these APs and 17 of them. I'm just opening a project that I prepared for this webinar, so it's a little bit faster. And now what I have in front of us is the high capacity design with dual band APs, and now I have 28, okay? So capacity health is a pass everywhere, and signal strength and everything else will be very solid. So now what's changed from the design perspective, look, when I highlight the AP, it doesn't cover as much as the access points with internal omnidirectional radios. When I right click, edit AP, now you can see that these APs, they are still ceiling mounted, and they have 9103, which is like a patch antenna that points down and creates a cone of coverage. So now I can add more radios to increase my capacity without really increasing my CCI. So in this design, I still don't have, I hope I haven't checked that, no CCI, okay? So I have no CCI and 5 gigs with 28 APs. Life is good, okay? So capacity requirements are met. Everything is happy, coverage is there, everything is great. But now I have 28 APs and 28 directional antennas, 28 cables, 28 mounting brackets, a more sophisticated design. And it will be like at least 2-3 times more expensive when compared to just moving to 6 gigahertz. I kid you not, okay? So that's pretty much everything I wanted to show you about this particular demo. So I will stop sharing. We'll go back to slides. And if you have any questions, shout either now or towards the end of the webinar.
Can I grab you?
Change antenna pattern versus reducing power, then yes. So we want to change antenna pattern versus reducing power. If you reduce power too much, you are hurting clients close to the AP. So don't do that, okay? If you are designing with directional antennas pointing down, you might reduce power a little bit because antennas will have passive gain and the clients in the effective coverage cell will still have great MCS rates. So you can reduce it a little bit, like by 6 dBm, for example, on all the bands that you are using. Yeah.
Thank you for that really great demo, Mac, and some really good questions were coming in whilst you was going over that. Before we jump into the next demonstration, one thing we wanted to say really is that when you do move to a wireless first or wireless only deployment, regularly checking and optimizing your wireless networks become more important than ever. I mean, wireless is the #1 main form of connectivity now for all of our client devices. No one wants to be connecting anything to cables anymore. But when your company, your business is running on Wi-Fi, when the Wi-Fi stops, business stops, you can't get into the warehouse, you can't scan that inventory, you can't get that stock out, you can't make your orders. When you're in an office and you're trying to have calls with customers, the last thing you need is a choppy video call whilst you're on a Wi-Fi, over a Wi-Fi call, and you've got a really big presentation to deliver. So the thing about wireless environments is that they change all the time, whether it's our networks making changes, whether it's people bringing in other devices that's causing changes, or physical changes in the environment that causes the network to behave differently. By going and just simply taking a walk around the site with the Psychic 2 and then syncing it up into Ekahau Optimizer, you can find so many ways that you can constantly optimize and improve your network by following these step-by-step recommendations. So when wireless becomes the main form of connectivity and you've not got cables to any of those desks or any of those other devices, we really need to make sure that us as the Wi-Fi engineers or the owners of the network is that we have visibility to be able to quickly react or proactively assess our environments and make sure we account and accommodate for any potential changes we need to make. And I want to give you an example now of just a small office that's in central London where they want to be a wireless only office. So they've got 5 access points currently deployed in this environment. You can see these. If I know we've got a lot of new people here to the webinar, so first of all, welcome. I hope you're enjoying the webinar today. And if this is your first time seeing Ekahau AI Pro, what Mac was showing you was a design file, a design simulation. What we're looking at here is actual survey data collected by someone going on site with our hardware, the Psychic 2, and capturing that data. And once you've captured that data, you can analyze it here in Ekahau AI Pro, in our survey application, or in our cloud where you have access to Ekahau Optimizer. But when we take a look at this London office, before we look at it in Optimizer, when we see it in here straight away, I think we're drawn to that there's obviously clearly going to be some issues. If this office was trying to provide wireless only connectivity for their devices, but what you can see here is that the primary signal strength for 5 gigahertz, we can see quite a lot of gray areas. So this means there's not even enough primary coverage to provide that good connectivity for our client devices to even be able to maintain some form of connectivity to the wireless network. And I can change this visualization and look at something along the lines of our secondary signal strength. And now when you see that's gone gray in a lot more areas, this means that when our devices are trying to move around the office, our mobile devices trying to go around the office, they're not going to have a great time or a great experience. because there's not that secondary coverage to discover and connect to that other access points. And if we was to have a failure of an access point, there wouldn't be enough secondary coverage nearby to provide that resiliency in coverage. So like when I'm looking at this, I'm thinking, okay, obviously there's some issues with some of the key metrics here. If it's not coverage, perhaps it's something to do with channel interference. But what I can do is I can go through this one by one, floor by floor, looking at the different criterias to try and work out and ascertain like what are these issues. And now, don't get me wrong, I've been working in wireless for a very long time, so I can do this no problem at all, and I can spot these things. But what I can also do is just let the data get automatically synced to our cloud, and then take a look at Ekahau Optimizer. So if you've not heard of Ekahau Optimizer, it's our latest product feature that we've released into our cloud, Ekahau Insights. And what we're taking a look at here, if I just re-sign in quickly and find the file. Whilst that's loading, it basically automatically analyzes your network and your requirements, and then what it will give you is a detailed step-by-step guide on how you can make improvements to your network. So you might be joining thinking, oh, I need to do a brand new design to be able to be on a wireless first environment, or make these optimizations, run new cables that we know are expensive. But that's just not the case. There's so many ways that you can improve your existing wireless network and make it more efficient and better for your users. So like, for example, when I look at this now, I can see there's obviously clearly some issues with the coverage. And if I take a little bit of a look into that, and I go into the inspect tab, and I maybe click on one of these points here, and I open up, I'll go back to the primary coverage, and I click on one of these gray areas, and I click on this little eye icon, and I have a look here, and I can see that the transmit power is down at 2 dBm, which is really low. So now when I come back to here, I want to open optimizer file. So let's take a look at this one. So what I could do is I could analyze the data in the cloud here directly and go through like just one by one those visualizations that we were looking at before, or I can just simply click on Optimizer, ask Optimizer, and it gives me this breakdown of different categories, different criteria, and it says straight away, look, it's red. You need to improve your primary coverage. And when I click on that, I can see this visualization heat map that we can see in the desktop software, and I can see that it's got issues with the coverage. And when I take a look at the overall best practices recommendations that we want to be achieving, then I check the requirements. If I look here, it says, look, increase your transmitting power to 14 to 17 dBm if it's currently lower. And I come back to here, and I can see that this access point, for some reason, its radio is turned all the way down. Maybe something's happened in the environment, caused the access points to power their radios down, but that's caused us coverage issues. It's caused us problems with the network. The devices, if they're trying to use the environment there, it's not going to perform or behave very well. And that's just one example from Optimizer. I can scroll through any of this list, like secondary coverage, and we can take a look at rogue devices. We've got some rogue devices here. If I click on it, it tells me where they are, which could be causing us some interference or some issues on our network. It shows us where we are, where they are. Maybe those printers that we were talking about that has their wireless enabled on them. So I can see them here clearly. I can go and locate them, remove them, reconfigure them, and get them off our network, because that's what's causing us these issues. So that's just a few things that we can see in Ekahau Optimizer. And then what we actually did is we followed these steps. So we followed, when we were there, we followed the steps from Ekahau Optimizer with all of these different step-by-step guides on how to improve the network. And then we reevaluated the environments. We walked around it again. So I wanted to actually just quickly show you the difference of the file. When I take a look at it now, the exact same location, no new access points, no new cable runs. Let me just look at my networks on 5 gigahertz. All we did is we just followed those recommendations, and we fixed the channels, we fixed the issues with the transmit power, and now you can see that we've got the coverage everywhere. So now they can actually go to a wireless first or a wireless only environment. And yeah, so it made a huge improvement. So that's Optimizer, and making sure that you're constantly optimizing your existing wireless networks to provide this wireless first form of connectivity. But the other thing that I wanted to show you very quickly that we spoke about earlier is that if you've got a wireless only environment and you've got access points, enterprise grade access points that have got these Bluetooth radios, how can we see or visualize that inside of Ekahau? So what I'm going to do quickly is just get rid of all of this survey data. And then let me place a few simulated access points. So I'm just going to delete that. And once that data is gone now, what I can do, I've got all of the walls information in here from the data we collected on site. I can just go and grab one of these access points, perhaps like maybe this one. And when I place the access point, if I just turn off names quickly, and if I zoom in a little bit, you'll see we've got the first number here, that's the 2.4 gigahertz radio. Then the 5 gigahertz radio is the number 36. And then this is the 6 gigahertz radio. But look at what we've got here. We've got that Bluetooth BLE icon. So if I now change the visualization from signal strength from 5 gigahertz to, let's say, Bluetooth coverage, I can now actually plan and design my BLE coverage from my access points, my Wi-Fi access points. So when I'm maybe taking into consideration where I want to plan and place my access points, maybe I'll put the APs in a similar location to what the actual deployment was. So I think there was a few access points around here, just like that. I could go back over to the signal strength coverage, and it looks very familiar, similar to that pattern that we saw in the last file. So we can see our Wi-Fi coverage here, but also now when I go to the Bluetooth coverage, we can actually see that the office is, completely covered in BLE coverage as well. But perhaps you want to understand in your office's environment how many meeting rooms are occupied, how many people in the rooms can I get access to it on certain times. And to do that, you may not want to actually install really expensive APs in the room just for the Bluetooth radio. So actually in Ekahau, what you can do is you can also design for using Bluetooth beacons just by coming to this access point icon, changing it to the Bluetooth beacon, and then you can pick one of the Bluetooth beacons in here, for example, Aruba. Then you can put it into all of the different meeting rooms that you've got around your environment. So you can then perhaps use that data and analytics to find out when you can and can't get access to these meeting rooms and have a better meeting occupancy rate. And then the last thing that I just wanted to quickly show you as well, that you may not be that familiar of, and since we were talking about some of our devices that we need to cable, is, well, I'm going to just drop something here called a map node, because I noticed something on this floor plan. If I just zoom in, I can see that there's a comms room here. So I can see that there is a comms room right here. So I can drop a map note to tell myself, okay, comms room, so I can see that. But then what if I want to work out the rough cable length from the comms room to my access points or to my BLE beacons, because we want to make sure it doesn't exceed, let's say, 90 to 100 meters in cable length. Well, what I can do is if I change this map note icon from the map note to cable note, what I can actually do is I can come to where the comms room is here, and then I can actually draw the path from the comms room to one of my furthest away access points, which could be up here, and that's coming in around 20 meters. If I go just to where this access point is, we can see it's around 23 meters. I just left click, then right click, and then I would just factor in a little bit of vertical cabling, so maybe like 2.5 meters on either side of where the comms room and the access point is. And I would just say comms room to AP1 is 28 meters. So then you can do that for all of your access points, all of your beacons, and you can plan to make sure that you've got enough switches, enough capacity, enough cable length, and if you need to potentially install some additional cables. So that was just a few things that I wanted to show you quickly, and I'll just head back over to the slides. Okay, and back over to you.
Thanks, Matt. Thanks, Matt. That was an awesome demo. So I learned nothing from you. Actually, no, it was good. Cool. So guys, since we are discussing wireless first, let's very quickly mention other things rather than just optimization and design, just optimization and design. Design is super important. Optimization is probably even more important, because the reality is most of us, we don't have the luxury of designing our networks or redesigning our networks. We get what we get. We inherit these networks. So our mission should be to make the most out of them. So the optimization is a massive part of our daily roles. But guys, outside of all of that, try to look at these three things. So these are called the amendments that make our roaming authentication faster. First amendment, 802.11, are extremely important. So you might have the best network in the world. If you don't have 802.11r enabled, and if you are using Radius server in the backend, then every time you authenticate to the network, to the Wi-Fi network, you go through full Radius authentication in the backend. Okay, that's fine when you do it once, but every time you jump from AP to AP without 802.11r, you go through the full backend Radius re-authentication, and it takes time, sometimes seconds, at which point your voice communication, voice call, conversation, your conference call, they are gone. Okay, so 802.1x networks with Radius in the backend always use 802.11r amendment on the Wi-Fi side, always, okay? When you do that, then you just initially authenticate against Radius, and then you don't have to do it when you roam between APs. Very important. Now, second amendment, extremely important, 802.11k, super important. You have to have it enabled on all the SSIDs. It doesn't matter what security you have, Open, PSK, SAE, or .1x, whatever, doesn't matter. Always have 802.11k, because what it does, when you are connected to the current access point, your current AP, and then when you start moving farther away from that AP, without 802.11k enabled, your client will be going off channel to scan for its next best alternative to roam to. And when it goes off channel, it's not being served by the Wi-Fi access point. So the more you have to go off channel, the more time, the less packets you are able to transmit or receive. Your voice will get choppy. It might take seconds for you to find another best access point or any access point you can roam to, at which point you are very far away from your existing connection because you are moving farther away from it, at which point you might drop off from the Wi-Fi network before you discover anything better. With 802.11k enabled, you can, when you get to the roaming threshold, your device gets to the roaming threshold, your device can ask existing AP, hello, my existing AP, please give me a list of your neighbors, and then I will scan them and see if they are good for me to roam to. So sometimes your AP will give you a list of one AP that it can hear, or two APs or five APs, but even if it's five APs, it's not, 25 APs that you have to scan or potentially have to scan. So 802.11k makes discovery while roaming, especially, so much faster, it will blow up your mind. And lastly, 802.11v, I'll pretty much ignore it here. If you enable it or disable it, most likely it will have zero effect on your network. I haven't seen it being beneficial even once in my life. I have seen it being problematic more than once in my life. Most of the times, it just works with V enabled or disabled. Long story short, V allows your infrastructure to tell your device to disconnect, or it will drop the device from the network, and it will suggest another best access point for the device to connect to from the infrastructure perspective. And client devices, from their perspective, they don't like it. Okay, so you are risking blackmailing the SSID if you have 802.11v enabled, and infrastructure tells an iPhone, for example, that it has to move to a different access point. iPhone doesn't move, and then it gets kicked out from the Wi-Fi network, and then it connects to the same AP. The same AP kicks it off again, and then iPhone connects back to the same AP. It's being kicked out again. Then it completely bans the SSID, okay, and it won't be able to connect anymore. So be careful. That's it, guys. That's the amendments. Sorry for running 1 minute over. And let's switch to questions. Matthew is smiling because someone is probably saying something funny about what I'm saying. No?
No, I just thought it was amusing that you said you're going to be blackmailing SSIDs and
blacklisting.
Well, I'm thinking, what have you got against this SSID that I don't know about that you are holding against it?
Yeah, right.
Yeah, I thought it was very funny. So that is the end of the content perspective from the webinar today, but we will stay and take some questions that have been coming in the chat. I saw lots of great questions in the chat, plus also the Q&A. So if you want to stay on for a few extra minutes with us, we will happily answer as many questions for you as we can. Let me just say one thing before I stop sharing my slides, because do you see my slides now?
Almost.
Matt Stalin has started screen sharing. Something is not working for you, my friend.
Oh. Never mind. It says resume, but it stops. Yeah, I just wanted to mention a few ways that you can get in touch with us if you wanted to give some feedback or reach out and stuff like that. So apologies. I took that down maybe a little bit too quickly there. But let's cover some questions. Stu, what questions do you want us to tackle first?
Yeah, I highlighted two really good questions here, part of this webinar, and this really kind of homes down on that that efficiency and the capacity that that we talk about in our great ECSE course, right? Is how much, when we talk about MU-MIMO, right? Per band, suggestions of questionnaires, how much MU-MIMO per band would you suggest for a company that's going to be using very heavy traffic? In a normal band, this is 2 to 3 megabits. And then the other one kind of follows in with it is, talking about oversubscribing, right? What are the considerations of migrating to that, those wired users over to only Wi-Fi? What would the capacity be like? I mean, or should we be worried about both the efficiency side of our MU-MIMO and the capacity? And then this also probably plays into the 6 gigahertz as well, but maybe a lot to unpack there, but maybe you guys want to tackle that there.
Yeah, sure. I mean,
efficiencies, yeah,
definitely quite a lot to unpack, but I think you hit the nail on the head. The when it comes to capacity planning and designing, it's not really just that simple math. I know I put that calculator up earlier where I was like, oh, just 20 users per AP, but that's not really how you would be working out capacity. You would be using our capacity planner in Ekahau AI Pro, and you really have to understand the capabilities of your access points that you have, plus the capabilities of most of the devices you're expecting to come into your environment. And then not only that, but also understanding that what are the applications that they're going to be using. Is it going to be mainly voice over wireless traffic? Are they going to be sending and receiving large files? Is it going to be, it might sound crazy, are they going to be using like virtual reality devices that need that bigger bandwidth? Because you need to take all of this into consideration. And then what our capacity planner can do is work out for you how many concurrent devices can the network that you've designed or the network that you've got installed actually be able to take kind of like in one go. And it's a bit of a fine art to try and like make sure you don't over spec it. And it's one of the things that we do really cover in the ECSE classes is that, if you let's say you've got an office that can have 100 users, 100 people that can come into your office, and then you ask the stakeholder, like, okay, so you've got 100 users that come into your environment, how many devices will your users have each? And they'll probably turn around and say, well, they've got a laptop, they've got their personal phone, they've got their corporate phone, and maybe some of them have a tablet or a smartwatch that's connected to Wi-Fi. So you go, okay, so that's 100 users with potentially 4 devices each, and that's like 400 devices now in this environment. And then you say to the stakeholder, well, what are these devices going to be doing? And he's like, well, sometimes on a laptop, they're going to be on a video call. Then sometimes on a mobile, they're going to be on a voice call. And then when they're on the iPad, they're streaming something that's coming from our station. So now you start adding up all of the bandwidth requirements for these applications on all of these devices at the same time. And then you look at the design or the network that you've got deployed and you go, oh my God, we've not got enough capacity requirements. We need more access points. We need more radios. We need more directional antennas to sufficiently cope with all of these devices. Then you take a step back and you go, okay, well, out of those 100 users, Mr. Stake or Mrs. Stakeholder, how often are all 100 users in the office or the warehouse at the same time? And they go, oh, you know what? People are that hybrid working now. Some are at home, some are in the office. Maybe around 50% on a good day. So you go, okay, well, that 100 users now has just gone down to 50 users. And then you say, okay, well, still 4 devices all simultaneously connected to the network at the same time. So you're on a video call and a voice call and you're watching something. And they're like, oh no, that's probably not right. Actually, you can't multitask on all of those things at the same time. So those 4 devices now that might come down to 2 devices. So you might be on a video call and then answering some instant messages. So now what you've actually ended up with is, instead of 400 devices with a crazy bandwidth requirement, you've now got 100 devices, because they're half the users, with a more realistic requirement, and can they benefit from taking a proper crack at the capacity planning. And of course, with the addition of the 6 gigahertz radios and the 6 gigahertz clients, and you've got more devices evenly-ish, or more, or we'll see more and more devices that go on to 6 gigahertz that free up those lanes that we were talking about earlier. Remember those 1, 2, 3 lanes, one for 2.4, one for 5, and one for 6 gigahertz. Having that additional lane does give us, that extra bandwidth and more benefits to our previous legacy devices. So sorry, I know it's a bit of a long-winded answer to the question, but there was quite a lot to unpack there. Hopefully I've answered as much of it as possible. If not, then always feel free to come on one of our ECSE.
Have you mentioned the MU-MIMO, Matthew, because it was a part of the question?
Did I mention it?
I think, yeah, I did cover that. I think it's definitely, I think, folks, is that if you're going to be looking for that MU-MIMO, remember that most of those clients out there today are going to be the 2x2 and 3x3. And when we get into that 6 gigahertz, that's when it really takes off, right? That MU-MIMO. And I think, Mac, you were talking about this, is that you've got that kind of, we're working that into more than into our 6 gigahertz ECSE now, right? Because we're covering 6 gigahertz now fully.
No, I was like
you're almost there.
MU-MIMO is like, it's pretty much a gimmick. Okay, in Wi-Fi, MU-MIMO works mostly when you have like, one massive antenna, and you have like 2 antennas on 2 sides of the building. The buildings on 2 sides, they don't move, and then you can physically like send different waves towards these antennas on both sides of the building. And MU-MIMO is designed to physically send RF waves towards the clients on different physical sides of the AP, and it adds so much overhead that it's practically not practical in Wi-Fi, especially when you have users moving around the access point, and MU-MIMO simply won't work. So I wouldn't be bothered with MU-MIMO at all. Okay, I see that we have 2 more questions that were highlighted to be answered live. Let's take the shorter one. Since the demo design is for capacity, what difference will it make if we design moving mobile view preset as against regular view? Very good question. So guys, in Ekahau AI Pro, you have a slider, like a tick box, view as mobile or not. If you don't view as mobile, then all you see is the attenuation, free space path loss, maybe reflections and refractions, depending on what model you're using. But typically it will be just attenuation and free space path loss. Okay, if you enable the button that Stu is now showing you, now around 8 to 10 dBs will be detracted from the RSSI that your devices will be seeing, okay, from the coverage. And that would translate to probably you designing with too many access points, because when you are designing to NEC 67, that's Ekahau best practices, we are already factoring in the lower sensitivity of mobile devices. So NEC 67 in Ekahau will translate to NEC 72, NEC 75, NEC 77 at the edge of the cell from the iPhone perspective, and it's perfectly fine. You already are factoring it in. Now, if you still want to enable mobile view and design to NEC 67, now you are designing to really, like from the free space path loss and attenuation perspective, to NEC 57, and that's just crazy. You will have way too many access points, and you don't need that. Remember that NEC 77 from the phone perspective is still perfectly fine. My wife downstairs through the concrete floor from my mobile router is working on NEC 85, and she's absolutely fine on a MacBook, okay? On her iPhone, it doesn't work anymore because it's like close to NEC 90, so it's a little bit too low, but like NEC 77 is still fine. So don't use mobile view. That will be my opinion, especially for designs, okay? Especially for designs. For validation, that's a different story, but for designs, never use that. Okay, another question was, what type of Meraki AP, that's from Fabian, I think he's left, would you suggest to install around the main shopping center hall, where very often it's crowded and Christmas, they install roller coaster, Santa Grotto, etc. A very long story short, if you have potentially crap loads of users in a small geographical area, like the roller coaster area, just install tri-band APs and you're good. Okay, as many as you can, like 10 or 12 meters apart, you're fine. If you have to still have more radios than that, then start installing patch antennas pointing down. It's currently very difficult in 6 gigahertz space because of the device classes and not having the AFC ready everywhere in the world, especially outside of the US. So you can't really use external directional antennas on 6 gigs. But if you are using dual band 2.4 and 5, then start using patch and sector antennas to divide the spectrum and reuse the frequency more efficiently, and therefore having better capacity in your Christmas network. I hope that answers this question. Anything else, Stu?
I think that's actually a wrap. Actually, we had some great questions that I answered throughout the webinar. We had some great conversations in the chat today. A lot of new folks, and it's nice to see you all. And remember, this is all recorded. You get to see it probably about Monday when the teams got everything wrapped up. But again, great work, guys. Super happy.
Yep.
Thanks,
Well,
guys.
Yeah, thank you all so much for joining us on this webinar today, and everyone at the Ekahau team, and you all for joining us. And we will be back in a few weeks' time. So make sure you're looking out for the next webinar, and we will see you all on the next one.